Hi, this is a set of data from Zimmer and Peacock. So Zimmer and Peacock, we have a bespoke cloud system called Julie. Anyone can sign up for a Julie account. It's a very powerful sort of data management system for primarily looking at things like electrochemical data. So here we have some data that was gathered in our labs, and we really do gather some high quality data. And I can see from looking at this amperometry that they've done it at sort of 0 millimolar, 10 millimolar, 20 millimolar, 50 millimolar. Um, and I don't know if I mentioned 10 as well. But anyway, there's several concentrations in here. And it's probably worth noting that actually they've also done it, when I say they, the great engineers at ZP, they've also done it at multiples at each concentration. So there's quite a lot of data there. Now I know this data is not perfect, but it does help me illustrate a particular point that I want to make, which is sort of how you can use Julie to look at the data in several ways. So if we go under Tools up here, what we've got sort of General, which tells me what's happened is every time we want to sort of analyze the data in a slightly different manner, I can add a one here, and this is amperometric data, and that will give me an AD3. I'm going to just delete that because I've done it previously, and what we've done is we've got a set of data and we've analyzed it. We've essentially got sort of three tabs here where we're actually looking at the peak area, or sorry, I should say here, the area under the curve. We've said this is the central time spot, like 120 seconds, and we're looking at when it says 240, what that means is my center point is 120 seconds. I'm looking at 240 and 0. If we look at AD1, it says my center point is 25 seconds, and I'm looking at 0 and 50. So that's my kind of range. And if I look at AD2, it says my center point is 180 seconds, and I'm looking at 280 seconds to 80 seconds. So we're looking at the same data, but we're looking at the integration or the area under curve at different times. And now, the reason I say that is because it's all the same data. And the nice thing about Julie is it gives you essentially KPIs, key performance indicators. It does statistics on your data, and so you can kind of determine what's good. So with the idea of integrating underneath the curve from 0 to I think approximately 240 seconds, I think we set this up to be, I can see that the limit of detection is 19. I'm ignoring the fact this is not great linearity data, but I can see that my limit of detection is 19. So if that's what I'm really focused on, I get a sense of whether I just look at the entire curve is good. If we narrow in and look at the first 50 seconds, then I can see that my limit detection is like 78.8. I'm ignoring the fact that it's not great linearity. And if I look at the last segment that was just centered around about, I think around 180 seconds, I can see that limit detection is actually 5. So you can see that we can take the same data, rather than treating it as kind of current versus time, we're actually integrating it and saying integration versus concentration, and we're able to say by moving this integration window around a little bit, we can affect the limit of detection. And it's really quick because, well, what's really nice is that that kind of analysis can take you some hours, or you may have to make bespoke code. But the nice thing about Julie is it just does it automatically. So Julie allows the conversion of amperometric data into coulometric data. Okay, if you've got any questions about Julie, don't hesitate to reach out to us. Okay, thanks very much.